Okay, so question number 4 says that you have to consider this logic statement given below, and then you have to draw a logic circuit to match the given logic statement. This is always a question in every paper. Okay, so take care of the brackets first, okay, because they determine that how you have to make the logic gate. So first we have 3 brackets. Okay, 3 brackets, then A NAND B. Okay, NAND is basically the opposite of AND. Okay, so write about that, A dot B, because it's AND, right? And then the whole input is NAND, it's the opposite, right? NOR. Okay, fine, then close the brackets. NOR is the opposite of OR. There's the plus, and the whole input is bar. It's because it's NOR. Okay, NOR. B and C, that means B dot C, and you're going to close it, and then another bracket, and then OR C. So this is the whole thing you have to work with. First of all, you have to do this separately, then this separately, and then you have to NOR these 2 things, and then you have to OR this whole output with C, right? So let's draw a gate. Okay, so yes, also read this, that all logic gates must have a maximum of 2 inputs. Do not attempt to simplify the logic statement. Okay, fine. Okay, now we're going to do A NAND B. So the NAND gate is basically, you need to know the shapes, you need to learn this. It's like AND, this AND, and this thing. This creates an AND gate, and NOR gate is also similar to an OR gate. You just need to have this circle in front of it, right? So now let's do it neatly. A dot B, bar. So I'll take it here. This goes here. So it's A dot B NAND, right? A NAND B. Okay, so it's basically going to be this gate, right? NAND gate. Okay, I think it's not the shape. Wait, I have to make it more clear and more precise. Right, yes, this one is okay. Okay, then A NAND B, and then you have to do B and C. So B goes here, you can extend this over here. Okay, and then this C, B and C. B and C, and then you have to NOR these both thingies. Okay, oh, this is not XOR gate, sorry. This is NOR gate, right? So just need to make an OR gate first, and then the circle in front of it, right? So this is my OR gate, and then I have this this input is gonna be OR with this C thingy. So let's do it. Need to extend this wire to this one, and this is this. Okay, this needs to go up and like this. Okay, and then it's going to be perfect, like over here. Okay, so you have to join it with X. It's slightly upwards. I'll make it like this. Okay, so now I finally get my what is it, logic gate, right? So you have this NAND gate, and then you have AND gate, and then you have this NOR gate, and then you have this OR gate. So they all have a maximum of 2 inputs. Now let's draw a truth table for the given logic statement. Okay, now it would be, first we'll do A dot B, stepwise calculations, and then A dot B bar, and then B dot C, and then A dot B bar plus B dot C thingy, and then this NOR, this is all NOR, and then the final output X is with plus C, right? Okay, so and let's write it here. A dot B, A dot B bar, and B dot C, and A dot B bar plus B dot C, and then the whole thing is A dot B bar plus B dot C, and then it's gonna be NOR, and then this thingy is going to be, over here you can write A bar dot B, sorry, A dot B bar plus B dot C, the whole bar, and then plus C. It's going to be this thing. Now let's do it. A dot B means multiplication. 0 0 0 0 0 0 0 0 0 1 0 0 1 0 0 1 0 0 1 0 1 1 1 and 1 1 1. And then opposite means that it's going to be the opposite of zeros, and this would be 0 0. Okay, then B dot C. Okay, so it's 0 1 0 1 1 1 0 0 0 1 0 0 0 and 1 1 1. Now you have to add these both, so it would be 0 plus 1 1 1 1 1 1 1 plus 1 is 1. It's not 2 because in computers we are always dealing with zeros and ones, and then 1 and then 0 and then 1. Now it's going to be the opposite of this thingy, so it would be 0 0 0 0 0 0 1 and then 0. Fine. And then the whole X input, because it's going to be plus with C, so put your fingers on it, would be like 0 plus 0 0 0 plus 1 1 0 plus 0 0 0 plus 1 1 0 plus 0 0 0 plus 1 1 0 plus 1 1 and 0 plus 1 is 1. So it's basically going to give you 0 1 0 1 0 1 1 1 as your final output X. Then the last question of this paper is question number 5. We have only 5 questions because I think there are too many parts to each question, like part E, D, you know, so it's fine. Okay. So Tammy is buying a new computer that has an LED display. Okay, 5 statements about LED displays are given. Tick to show if each statement is true or false. Okay, let's see. LED, it has a flat panel display. Yes, we have LEDs in our homes as well. So it's basically a flat panel display. And then it creates images using red, green and blue diodes. Yes, it does. Okay, LED, you know, yes, the primary colors are used. Then it is not very energy efficient and gives off heat. No, it's false. These were the old, you know, monitors, LCD monitors, which were backed by the CCFL technology. And then it can be used in mobile devices such as smartphones and tablets. Yes, it can be. It's a fact. It is a front lit display. No, it is not a front lit display. Okay. Now part B of this question says that Tammy connects the computer to her home network. Okay, the computer has a MAC address and an IP address. Okay, and an IP address. Then a paragraph is given about MAC addresses and IP addresses. Now you have to complete the paragraph using the list of items given. Not all terms needs to be used. Okay, fine. A MAC address is a media access. Oh, it's asking about the abbreviation of this, the full form of this, right? So you can write it's media access control address. Yes, control is given, so it could be media access control address. Then a network device has a dash MAC address that can help dash the device in the network. Has a unique MAC address, because MAC address is unique. Let's see if we have that. Yes, we have it. It's a unique MAC address that can help identify, maybe because other things don't match, right? That help identify the device in the network. An IP address is an internet protocol address. It's the full form of IP protocol address. An IP address can be static or dynamic. So dynamic is also given. Static means that it won't change each time user logs onto the web browser, while dynamic is that the IP address may change. Okay, each time, every time the user logs onto the web server, or uses the internet. So then Tammy uses a browser when accessing the internet. You have to describe the role of the browser. This question is the same as describing the function of the browser, or how does the browser works. Okay, so they just change the words in the English language, but the purpose of the question is the same. So it's again a 4-mark question as always. So now you have to describe the role of the browser. So let's write in points, because we need 4 valid points. So the browser, basically it displays your web pages, right? Okay, a browser displays these web pages. Okay, and then how does it display these web pages? It basically translates the HTML code, right? So it translates the HTML code. Okay, and then the third function is basically it creates your tabs. You can create multiple tabs, right? It creates tabs, and then it stores your history and your preferences. So you can write that it stores user history and preferences. You always have your history of search history, right? So you can write that preferences, right? Okay, spelling is this one. Preferences, okay, fine. A browser displays web pages. It translates the HTML code. It creates tabs. It stores your user history and preferences. It also retrieves your cookies as well. But for 4 marks, 4 points are good enough. So okay, this was the last question of this paper. Thank you for watching, and I'll see you soon within another video. If you have any queries, you can always ask them in the comment section below. Thank you.